Thanks for watching LaurieWired, and in this video we're going to learn how to call functions inside of ARM assembly. Now there are a couple of special branching instructions that we're going to have to learn, and these are going to set something special called the link register, and this register is going to contain the next address of the next instruction that's going to be called after we actually finish our method call. Additionally, we're going to use the stack to save the state of certain registers before we actually perform our method invocation so that we don't lose that data during our call. So let's get right into it and see what it looks like. First of all, I'm going to pull up my Notepad++, and this is just a really simple example C function that I wrote that's going to add two numbers together and then return their sum. And you can see we have our declaration, which is going to be kind of like the label that we're using in our ARM assembly. Then we have the corresponding method name that's going to take the constants that we're adding in this case. So let's just go through and see what that looks like inside of ARM assembly. I'm going to pull up my CPULator, and first of all, let's begin looking at what parameters we have. We have the constant values 1 and 2 that we're passing in for this particular case. So I'm just going to take two registers. We're going to do move R0, the immediate value 1, and then move R1, the immediate value 2, to signify our actual arguments that we're going to be passing into this addNums function. Now, one special thing to note about ARM v7 assembly, every single assembly language is going to have its own calling conventions, but for this particular language, it's expecting the arguments inside of the first four registers, so that's going to be R0 through R3 are going to be the actual arguments to the functions. Now, our first argument is going to be passed into R0, our second argument is going to be passed in R1, and then if we had other arguments, they would be passed into R2 and R3 respectively, and then the remaining ones would be pushed onto the stack, but we just have two in this case, so we don't need to worry about that. So I'm just going to do a quick comment here. We're going to call this arg1, and then arg2. So we have our arguments figured out, but now we actually have to specify what is the name of the function that we're trying to call. I'm going to do down here, and I'm going to create a new label, and we'll call this addNums, just like our function name. And then our instructions are going to go inside of here, where we're just going to add these two numbers together. So what we can do is we already know our add mnemonic. We can do add R0 and R1, and we're going to store the result inside of our R0 register. Now, another thing to note is the return value of functions inside of our ARM v7 assembly is going to be stored in this R0 register. So if I wanted to take the return value after my actual function call of this addNums function, I would check the R0 register to actually get that value. So now I have my function defined down here, really simple function. I actually need my method invocation, and this is where our special branching instructions are going to come into play. We're going to introduce a new one that's going to be called BL, and then it's going to specify the label that we're trying to jump to. Oops, still need our label there. Now this BL instruction is going to be called branch with link, and this is one special instruction that's going to set that link register that I mentioned earlier. So this is going to branch to the specified label, just like we do with all of our other regular branch instructions, but it's going to set that LR register. And if you want to take a look on the left-hand side inside of CPULator, you can see the LR register that's specified over here. And this LR register is going to point to the next instruction that's going to occur after our actual branch with link call. Now, if I put another example instruction down here, let's say move, maybe we want to put our return value inside of something. So we'll move R0 inside of maybe R2. So that's going to get the return value. This link register is actually going to be specifying the address of this instruction, since it's the following instruction after our actual branch with link call. Now you might be thinking, okay, we're branching to this addNums label over here, but we're never actually exiting out of it and returning, and you would be completely right. So we do need another special branching instruction that's going to bring us out of our actual function call. And this is going to be called bx, and then it's going to specify that link register that's going to contain the next address that we stored in using this bl instruction. If you want to take a look at the reference for this, this is specifying the actual register that contains the address of the location that we're about to jump to. So right now the link register, LR, contains that address of that next instruction. So I can pass the LR register to this bx command, and then it's going to cause the execution to go to the address specified by that actual register. Now if we go back here, we can see bx LR. LR is going to be our actual location of this next instruction, so we should be good to go and pretty much back to normal execution after our function call successfully. So the next thing we need to worry about is actually saving the state of our registers before we perform our function call. Now you can see inside of our addNums function that we are changing the value of R0, but let's say we're inside of our main function and we want to use that original value of R0 somewhere down here after we've made our function call. Well, we wouldn't be able to do that anymore because the actual original value inside of that register has been overwritten inside of our addNums function. So now we're going to actually push these values to the stack before we perform this function invocation so that we can save their state and not lose that data. There's going to be a couple special instructions that are going to allow us to do this. The first is going to be push, and then we can specify a list of all of the different registers whose state we want to save. In this case, I'm going to save R0 and R1, and now these are going to be pushed to something called the stack. Now the stack is an extra location in memory that's going to be used really often inside of your code for storing local variables. You notice on the left-hand side, we do have a finite number of processor registers. So if we wanted to store additional data that didn't fit inside of all of these, we do have the stack that can save the state of these registers during our function calls, or even push additional data to the stack if we're running out of space inside of here. Now data is going to be pushed on top of the stack in memory, and then we have an additional instruction called pop that's going to pop the value that we last pushed onto the stack and then store it in the register that's specified. Now if we put our pop instruction right after our function call, it's going to take the top two values that are on the stack, and it's going to pop those two values back into the two registers that I'm about to specify, and then it's going to change the state to what they were before this BL instruction. So I can just do pop, and I'm going to do the same two registers because these are the ones that I'm trying to save, R0 and R1, and I'm actually going to store my return value of R0 before I pop the value back on, because that R0 register is going to be overwritten when I actually call this pop instruction. So let me just do that. Now let's walk through these instructions. We're pushing these two registers onto the stack. So R0 is getting saved, so it's going to be the value 1 is going to be saved. R1 is getting saved, so the value 2 is getting saved. We're branching and linking to the addNums function, so this LR register is going to get saved and point to the next instruction to be executed, or the address of that instruction. Then we're moving in the return value passed in our R0 register. We're going to save that inside of our R2 register, and then we're going to pop off the top two values from the stack, and then this basically does the same thing as restoring the state of this R0 and R1 register to where it was before we actually made this branch call to our function. And if we want to go over and check the syntax of the push and pop instructions, you can see push here or pop here, and then it's going to specify the list of registers as a comma-separated list, and you can put on there whatever thing you want to save, any register, including maybe the link register, the program counter, or anything like that. Now if we go back to our assembly and we want to run this and see what it looks like, let's actually see what our different state is going to look like while we're invoking this method. I'm going to go compile and load. Looks like I didn't type anything wrong, so that's good. So here we are. passing in our two arguments. Remember, this is going to be argument 1, argument 2. So we're going to do step over, step over. Now the arguments are going to be in R0 through R3 registers. So we have our first argument, second argument. And now we're going to be pushing the state of these two registers onto the stack. So if I go over to memory and I type in SP, this is another special register that's going to point to the top value that's currently on the stack. You can see it's pointing right here, right now, at 0, 0. It's specified over here. But if I go through and I step over this push instruction, the actual value of my stack pointer register changed. And if I go back to memory, I can now see it's pointing here, and we have these two values pushed onto the stack. We have the immediate value 1 and the immediate value 2, since those were the current values stored inside of our R0 and R1 registers as our function arguments. So now we know that's just living in memory somewhere, and that's being stored and actually saved for us so that we can go back and find it later if we need it. Let's go back to our running program. Now we're to our branch with link instruction, and this is going to take us over to our addnums label. Just like this function call would do over here, that would pop us into this addnums function. I'm actually going to step into this so we can see that function execute. You see we have two options, step into or step over. Step over would actually skip this function call, so the next instruction that we would execute would be this move, but we want to go into it to see it execute. So I'm going to do step into. And now we're inside of our addnums function. We're going to perform our addition, and we'll do step over. Now the actual sum of these two arguments are passed inside of our R0 register, which remember signifies our return value. And then we're calling our final special branch instruction, which is going to be the BX mnemonic, and it's specifying the LR register. And if you take a look at the LR register, it's specifying the hex value 10, which is indeed pointing to the next instruction after our branch with link instruction that's going to continue our flow of execution. I'm going to do step over, and that's going to take us out of our function. Then I'll move over my return value in R0 over to R2 just to save that. So now that's going to be containing our return value. And now this pop instruction is going to remove those top two values that are currently on our stack, 0, 1 and 0, 2. It's going to change the stack pointer to not point to those two values anymore. So I'm going to step over that. And you can see we changed the state and popped the top two values off of our stack. And now those are stored again in R0 and R1, which contains the original values that we already passed in at the top of our program of 0, 1 and 0, 2, and we still have our return value that we put inside of R2. And lastly, you can see that our stack pointer was actually decremented so that we aren't pointing to those two top values anymore. We're actually pointing to the next value that was pushed on the stack. In this case, we had nothing else on there, so it's just pointing to 0, 0. That is how you can successfully invoke methods inside of ARM assembly. So thanks so much for watching LaurieWired, everyone. In this video, we learned how we could invoke functions inside of ARM assembly. We also saw how we could use the special link register to actually store the address of the next instruction that we're going to execute after our function call, and how we could set this value using special branch instructions called BL and BX. And finally, we saw how we could save the state of registers using the push and pop instructions to actually push these values to the stack, save them, and then pop them off once we were ready to restore the state. So thanks so much for watching LaurieWired, everyone, and I'll catch you in the next video.